Okay, so we are being recorded now. There was no questions, none, no homework, anything? Okay, well, today starts really algebra. This is really the beginning of the course, if you will. We're gonna start doing algebra. We're gonna start solving equations and whatnot. You have almost certainly in the past solved some kinds of equations yourself. Oh, look at that, look at that. Do you see what I did there? Uh-oh. That's right. Gotta watch that stuff. All right. They were gonna be starting solving equations. Algebra is very useful. It's even useful. I've had occasion to use algebra in not I mean, in real life situations where I didn't have to do it for an assignment. It is actually useful math. Or not do. But I want to start something. I want to show you a problem. 2 times 3 plus 4. So I'm giving you an expression. You tell me what part can be used. Well, you do the multiplication first, right? So when you do the multiplication first, step 1 is multiplication, right? And then what do you do? The addition. So what do we get for this answer? Right, 2 times 3 is 6 plus 4 more. We know that this it's an easy expression. You'll be tasked with this. And you'll be asked to find the value of x. So x is an unknown quantity to you right now. But as you work through, what we know that 3 works, right? Just from the thing I did before that. But if you didn't know that, you have to go and find the value of the unknown quantity that we're calling x for the time being. And when I write 2x, do you know that this means 2 times x? In fact, there's a name for numbers that occur right in front of a letter like that. Do you know what they call them? You probably do, but you can't remember. Coefficients. Ever heard of that phrase before? Those are the numbers that appear in front of the letters. What we're going to do then, like I said, we did this in 2 steps. The first step was multiplication. The second step was addition. Now, when we go to solve, we're going to do a lot of practice. So this isn't, don't think that we're jumping right into this just yet. What happens here is you wouldn't figure out the value of x. You have to go in reverse. So, and you have to reverse all the steps that you did. So I added second as the last thing to do. So what do you think I'm going to do first here? Subtraction and subtract. The way we usually do it, but the way it looks when I do it is, I will minus a 4 from this side, and I will also minus a 4 from the other side. So I'm subtracting first in this process. Now, what you want to do, please follow my advice. I've been doing this, as you can imagine, a very long time. Keep the equals all lined up and give yourself lots of space so that you can see what you're doing. Keep things lined up. I'm serious. It's very important to do that. All right, what's 10 minus 4 equal to? 6. And over here, since I subtracted 4 from both sides, it left just 2 times x. Have you guys seen this kind of stuff before? It's not completely foreign. All right, now, when we did the original problem, I did the multiplication first. First, So I'm gonna take care of that second, but I'm gonna reverse it. What's the opposite of multiplication? Division. I can divide by 2. This is the way I usually draw it. The reason why you do this is these cancel out. And all that's left is the letter X, which is what we want all by itself, isn't it? Which we knew the answer was going to be 3 before we did this thing, but. So solving an equation is to reverse the order of operations. Okay. Let's write that down. On. So there's 2 pieces there. You've not only got to go in reverse, but you've got to invert each of the things that you did. I'm gonna throw another one like this up there. I want to see how you handle it. And then we'll go and let's do that with the book. So let me show you the way it's usually listed in terms of solving, but you'll see this. They'll just say this. Solve, solve. And you might see something like. Okay, now, pretend there is a number where X is, right? You would normally do 2 times X first, and then you would subtract, correct? Let's reverse everything. Take a minute, I'll come around. Do it. Yeah. I swear to you, how good I. No, I'm gonna. Or do that first, and then. So normally, when you would go, if you knew the value of X, you would do 7 times X first. And then you would subtract 9. So the first thing I'm gonna do is reverse, so I'm gonna add 9. And then I'll divide by 7, that reverses the multiplication. One's gonna keep your stuff lined up. I will make, reference to the left and the right side of the equation all the time. That's why I keep it lined up. So it's clear which is the left and which is the right every time. Good so far. Let's see what the book has up its sleeve. And I forgot the password for the thing, so I'm going to go through Blackboard. The same thing happened in my office. I don't remember my phone number to my office. I never call it. I had to look it up today. All right, let's see, Alex. That's right. We got to press that little thing, don't we? Yeah. The new window. That's the trick.
There's our book. So we're doing 3.1 right now. Is that chapter? Oh, no, I don't do that. It's terrible. Heck. There we go. So now the equation that I gave you was, I think I'm just gonna go right into solving equations. And I'm not going to. Let's step through these things and try to get you lean, mean equation solving machines by the time you walk out of here. Okay, now you're asked to solve it, but there, I noticed the question in the book says, can you identify this as either an expression or an equation? This is an equation. What do you think it is that tells me that it's an equation? Something equal sign. No equal sign, it's simply called an expression. Okay. But nonetheless, solve this just like the other one, try to do. Perfectly fine. The answer is a weird one. I want to see how people react when they get something that doesn't look so great. I would leave it like that. No requirements do that. Okay. Zero. So you added 3 both sides, right? Base of 5n is equal to 9. If you do now, you divide by 5. Okay. When we can do that, that's perfectly fine. The decimal is not wrong, but I'm just saying fraction is perfectly fine. In fact, I'll address that. Let's solve this one here. This one happens to give you a fraction for an answer, which is possible. There's no problem with that. So tell me, what's the first thing you would do here? Add 3 to get that out of there. And what you might do as well, when you do these things, is if it helps you, maybe you put a slice through it so you know that you're getting rid of that thing, right? But now you got to do whatever you do to one side, you have to do the exact same thing to the other side of the equation. That's a basic principle of mathematics. Let me bring down this equals. I get a 9 on the one side, and on the left, I get 5 and 10. Now, what's going on between 5 and n? What are the technically is the operation there? 5 times then. So what's the opposite of that? And divide now. And this is a perfectly fine answer. There's no requirement to change it to a decimal. There's no requirement to change it to a mixed number. In fact, I would recommend you don't do either, because some fractions don't have, have an infinite expansion of decimals. You know what I'm saying? You won't be able to
to write the decimal and give me the exact answer to it. So this is the easiest way to do it. Just leave it as 9/5 and that's perfectly fine. It's done. Okay, so any equation like this really involves exactly 2 steps. And that's it. 2 steps. And now, we'll get more complicated ones after this, where there'll be more things to do before you start solving. But for now, that's about as hard as they're gonna get. So let's see what this book has for some more questions. This is all the class. It's solving equations, trying to make you really good at it. Let me stay away from those for the time being, those two. Go ahead and try these two. You see this, these are even easier than the ones we've been doing. That's not positive 10. Not being distracted, don't you go out. Did I check yours? Yeah, okay. So, go ahead and do these now. One step, both of these require one step. So on the first one, on 26, we have z plus 8 equals -2. Give yourself more space, spread it out, give yourself, don't, I see that, that's one of the things I see students, like paper is precious or something, I mean, maybe it is. But I have plenty of this. You want to make z be by itself, so you need to undo this positive 8 with a minus. That will leave just the letter z over there. -2 minus 8 more is -10. The question about that. Then on the second one, what do you do here? What's the one step? Subtract 10 from both sides. Then 4 minus 10 is equal to -6. And then over here would be, I personally hate when I have b and 6 on the same equation because many times they look the same the way I write them. Questions? Okay. That's what I want that. Try those. That's negative. Oh. Why did you feel necessary to keep that R down this way? You didn't feel that way. You didn't have, to, but I don't know why. Okay. The reason, because one of the reasons I asked this question was simply because it had the arrows on the other side. And students do this sometimes, and I'm not sure what they do that for, but
Oh, it's on the other side, or I don't know if it's on that.
it doesn't matter what side it's on, as long as it's by itself. That's all that matters.
so when we take a look, you'll know what it is. Either way, so. In number 30. I simply asked this one because the R was on the other side of the equal. And this is what happens, I think, when students get to something that looks different than they've ever seen before, a little bit of panic occurs. And then we come along and say, no, just use the tools you know how to use, and it will work just like every other problem. So I still want to get the letter R by itself, that means I gotta work this side. I'll subtract 14. That's all there is. Article 9.
On that.
It doesn't matter. If you put it, if you must have your letter on the left side, and that's the only way you're gonna operate, fine. I don't care. In number 31, what's the one step that we should do? Add what? Add 2.9. You want to get it away from the A. So we'll add 2.9 to both sides. And I guess it's a little practice on your arithmetic with these numbers. Which number is the dominant one here? The negative one, right? That means this is going to be negative. So what do you do when they have opposite signs like that? Somewhere off to the side, you do a computation like this. 3.6 minus 2.9. And you'll find that that is 0.7. That means it's going to be negative. 0.7. Okay.
As I told you, they're just, the essence is not gonna be any different than than the other problems. It's just more complicated. If you'll allow me to say that it's not harder, but it's more complicated. So you still have everything at your disposal to solve the equation. They're just fractions are involved now. Right.
You probably almost certainly added where you should have subtracted or vice versa. Issue plus and from. This one, not any more difficult than the other ones, you're still gonna do exactly the same stuff. What's the step? What's the one step you should do? Well, before you find a common denominator, what do I wanna do? Get this thing out of there, all right? Add 5/4 to both sides. Now you're on the left side, and the right side, this goes away. This side here will require a common denominator. You should remember that when you have two different denominators, you get a common denominator. So when you're gonna see it's -2/5 plus 5/4. I'll tell you something, when you're getting a common denominator, does anybody know what will work, by the way? 20 will work, both 4 and 5 going 20. In fact, 4 times 5 is equal to 20. They may have not have told you about this, but did you know you can always take the product of the two and that will work as a common denominator? Always. It may not be the least common denominator, but it will work. Anyways, when you're doing this, I recommend the following. Watch this subtle difference that I'm going to draw here. See what I did? No, I didn't do anything different except one little thing. What little difference is mine and the second one than on the first? The negative moved up to the 2, didn't it? Because I want you to think of -2 because I don't want you to think that the negative is down below or somewhere where it's going to be complicated, things complicated. So now I see that I just have denominators 4 and 5. So what we typically do is, and it just so happens in this case, the LCD, as we call them, the lowest common denominator, happens to be 5 times 4. The way I do fractions is this, is I know they're both going to be over 20 now, because that's what my common denominator is. I have to try to figure out what I did to make them. So right here, this 20. How did I change that 5 to a 20? What did I do?
By 4.
I multiplied it by 4. So I have to multiply the -2 by 4 as well. So what if I multiply -2 by 4, what is it? Or negative. Are we okay there? I back away slowly. Now the other one, can you tell me what the new numerator is for the second fraction? 25 over 20, because that one you had to multiply by 5. And now, when you add two fractions together with the same denominator, it gets that denominator, but we simply add the numerators. So -8 plus 25 is positive 17. But here, and just leave it, you don't have to do anything like that to ask more. In fact, once you've got the answer, if you continue to do things to it, you're giving yourself a chance of getting it wrong. Doing things to something that was already right, leave it be. Questions? As you see, they get messier. Maybe that's more complicated, messier. I don't know what you want to call them. You wouldn't believe some of the equations that I've had to do in my life. But you'll get an inkling as this course goes on. Yeah, let's do a couple of those. This deals with your ability to navigate through negatives. So we'll see what happens here. Once again, give me some sort of an indication when you finish these, and I'll come around and look at them. What's the 24 that we don't get? Oh, no, you gotta get the B bites. You don't need that, so you don't need that. Leave it alone. So I need to make the first one pretty evident.
This is, I see it was a good idea not to skip these, because they do require a little bit of discussion.
Start with 40. Do this to remind yourself. You see what I put in there? Big, fat, juicy multiplication dot. Well, I do that to remind myself that I'm not adding. I'm dividing by -8. This way, what happens here is that these cancel, and what's the only thing that's left over there? That's what you want to happen. 24/8 is equal to +3. I just cancel. So those that struggle with this, try the second one, see if you can get it. Put a big fat multiplication dot in between there. Alright. That was -8 times B. That's why I divided. 10. So put a dot. Now you're dividing by that -8. Line, negative. Hmm? All right, and the second one, same deal. I'm gonna put a big dot so I can tell what I'm doing with the thing. So this is -4 times R. I'll simply divide by -4. And now we have, you have the negative divided by a negative cancels. Anybody know what 48 divided by 4 is off the top? What?
I wonder how long this goes till, probably like 100 or something. As high as I thought, okay. These are some of the ones like we were doing at the beginning. All right, I'll grab. Let me start easy and then we'll work our way up to harder ones. Let's do 60 and 61. Remember, you don't have to make your answer look any certain way. Once you get the letter off by itself, you're done. You don't have to do anything else. So your goal is to get the letter by itself.
thinking. Maybe plus. Then I would add. You're dividing by seven, and I'm divided by six. Here's what. You can't answer this, that means there's still be a negative one. Negative B, right? One back. Negative eight divided by nine. That's what you would have. Like, if you don't more, I forgot that, it's like you went on the side. What happened to that? You're doing anything wrong. Correct, sorry, Mr. Fine. Shots. Right, good job. Good. Yes, I think that's right. I think the sign is wrong. No, not yet. He said it, remember, that's the guy you want to be by himself. Remember, you open one end up with M equals something. As you can imagine, your homework assignment has about 1,000 of these things. Number 60. Let's take a look at it again. This is a two-step process. So we want to make sure the M is all by itself when all is said and done. Can you tell me what the first step would be? Subtract 7. Subtract 7. Because if you have plus 7, you want to undo it by subtracting it. So I'll snug a -7 under here and a -7 under here. I'll leave a 10M on the left because these cancel away. What's 7 minus 7 equal to? 0. And then the last step, remember that's 10 times M. So I need to divide by 10. Since in situations like this, when you're not comfortable with the math, some people will get the correct answer and some will not on this very last step. Let's see what you have to say. What does that equal? 0 or undefined? 0. Now, here's what you do. Take your calculator and do it. Your calculator will actually tell you if it's defined or not. It's zeros. That is your math, doesn't it? You try to do 10 over 0, it will tell you, no. That is undefined. So M equals 0 is certainly an answer. And plus, you can do it in your head. If you put a 0 into that spot, this is how you check. So in number 60, let's say I go to number 60, I have a check. You can take the original equation and replace the number back in there. And see if this actually equals out. Does that actually equal out? It does. 10 times 0 is 0, right? So once you have checked yourself enough to know you're right, you can just go and check. I check. I typically don't check them, but it's obviously a good habit to get into. Questions about this? Now the next one. What was that? It's 5 minus. Is that number 62? Was it 61? 51?
And I feel, being the professor of this class, I do feel it's my job to give you good advice if I can. And you see that T there? Please do not do your T's like that. And look, people do it. Even the classes that I tell them not to do it, they do it, and you'll never guess what they confuse. What does it mean? So if I can put some curvature on my T so that I don't fall into that trouble. This here is number 61, yeah. You need to have a 61, the second one, 61 or 62? Right. Now, where's the steps on this one? Once again, same idea. This time you're gonna get the letter T by itself. So what's the first thing I'm gonna do? This is the guy you want to clear out. This is the side you want to clear. Except for that.
Negative 11.
Negative 11. Was that negative? That was negative. Oh, okay. I wrote it down. Negative 11, you said.
Yeah.
Okay, so do plus 9 here. Plus 9 here. Are we good on that? Then just finish it off. What's the next step?
Divide by 5.
Divide by 5. Or then 5 times T. And that answer perfectly fine. Don't have to do anything to it. Questions? Oh yeah, what are those things? Let's go ahead and grab 65. Well, I'm satisfied. So this is a new style of problem. And I kind of let you find out the nuances why you're working, and we'll talk about it. So as before, you want to subtract 7 from both sides. You want to subtract 7 from both sides. This is a little bit weird, because that is 1/2 times D. So what should you do with it?
How about 2?
You can multiply by 2, but technically speaking, since it's 1/2 times D, what did I tell you you're supposed to do when you have a times?
Divide by
Divide. So this is, we're in a couple of, we have several things we can do here. So I'm going to show you the ways that we're all here either. I'll show you a couple of ways to do this. Let's move this up. Down. All right, let's take a look at way number 1.
as mentioned, multiplying by 2 is a good idea. In fact, you might want to do this. You rewrite the whole thing or do it like this, kind of do 2/1 times that, and do 2/1 over here as well. You see what the 2/1 is going to do? It's going to wipe this out and leave just D. What's going to happen over here?
Just done.
If you want, give this 5/1. 10/1, which is just. That's way number 1.
This is more direct. But you see, it's because you're not quite doing what I said you're supposed to do in the installments. You didn't actually divide, you multiplied in a certain spot instead. But and that's another thing that's painful about these, is there are many ways to do equation solving. That means you might have a way that you like doing it. I'm never doing that version of it on the board. So we gotta watch and try to keep up that way. So way number 2, I'm gonna do what I said before. We have 1/2, I'm gonna emphasize that it's 1/2 times D, and that's equals 5. And then I'm gonna divide by 1/2. So I'll divide both sides by 1/2. See, and I don't like this method already, because while the left side is no big deal, these things will just cancel out. You will get D by itself. What do you do with the other side? It's complicated. Because you have a whole number divided by a fraction, it's not even a fraction divided by a fraction. So how do you work that side?
You can just make it into 0.5.
You can make the 5 a 5/1. That way you can make this 5/1 times 2/1. Nope. The same thing. And so you can do either of these ways. As long as your arithmetic is sound, you go a variety of ways to, I would probably stick with one method for everything as much as I could. And every so often you'll have to do something special if it's a weird question. Any questions about that?
I said the equation, they just get math here as we go.
This is kind of like accounting. You have to keep, whatever you do to one side, you got to do to the other. Go ahead.
When you divide, any fraction, which one does it matter which one you flip?
Yeah.
The inverse of, is it always the second one?
Mhm. That's just the thing. I mean, when you got a whole number, some people might want to do like 5/1 divided by 2. If you start thinking things like that, it's overcomplicates it, I think. Up over here. All right, let's grab some more ones with fractions in them. If you're looking at me to blame me for the problems, I didn't invent them. Yeah,
I think,
it's going on.
second one, good. That one. Is that equals? Yes. Equals, okay, yeah, great. Back and forth, that's how. Now this is 1/3 times that time. See, you see that? Where? Yeah, that's better. So you were correct in the 7. Why is that 7 there? I think why you used it. Right, where the 7 is there. You're right at the left side. You didn't stand this out right. Looking after 1/3. And then looking at the patient dot. Why did you put one? Okay, it's how you link through it. Now, how you gonna? You gotta divide both sides by 1/3. But do the other side as well. That was -3. Correct. I'm sure the way. That was, what should we do? We start with the way. Oh, yeah, I checked here or something. So you divide, you gotta do it to the other side though too. If you divide by the left side by 1/3, you have to do it to the right. All right, once again, these are all 2 steps to pretty much handle all of these problems. I'm gonna subtract 4 from both sides. That gives me a 1/3 x equals 7. And pick your way, if you want to clear the 1/3 out of there. I personally would rather multiply by 3. Instead of divide by 1/3, it looks ugly. So I'm gonna multiply both sides by 3/1. And if it helps, put your 7/1 so that you remember how to multiply. So over here, we get a 21. Both ones, and over there, they cancel out. Number 67. Let's see, 4 is 8 minus 9. Well, it's if I got it right. Yeah, sure. Yeah. All right, so what would you do first here?
Add 9.
Add 9.
First, yeah.
I forgot the negative myself. Fix these equation here. All right, -13. So I'm gonna add 9 to both sides, plus 9.
plus 9. -4 on the right. On the left, we have 4 fifths. What would you do now?
Multiply it by 5/4.
That's right, multiply it by 5/4. Do you guys understand why I'm multiplying by 5/4? What is that? That is gonna wipe out the coefficient. And that's exactly what I want to happen. So really, this is the realist kind of problem here, is that you had to clear out, with a number that's more complicated than just a whole one. So I'm gonna multiply both sides by 5/4. And make sure you do it to the other side, so make this 4/1 and then 5/4. Now, what's the point of that? This cancels out all the way, leaving b by itself. And here, there's some simplifying that goes on in here too. I'm left with -5. Question? So this represents another step in the evolution of the types of problems that you're going to have. Notice that you see several instances of the letter occurring. So before I show you how to do this problem, I'm going to let you try it on your own. Let me tell you something that you should do first. Whenever you're solving any equation, you should simplify each side of the equation first, then go about the solving process. So what I mean is, on the left side, when I say simplify, what does that mean? Combine like terms and all that stuff. Right? Minor like terms, yeah, rewrite, let me see what equation you have after you find, rewrite this equation, let's see what you got. Mhm. So the first thing, as I mentioned, the first thing you ever want to do always is simplify the equations. Or each side of the equation. So that's what I'm going to do. Simplifying means combining like terms. So what I personally would do, I think, I don't know if I mentioned this to you, but do you know that you'll do better? I don't know how you are all in that, but if you write more than you are now, you will do better. Simply write more. So what I'm saying, when I say write more, look, I'm going to rewrite my equation so that I do little. So 7m is 2m. See 11 minus 5. Do you remember when we were simplifying things, I would put the like terms by each other. Right? Now I can combine my m's. How many m's do I have? 9 m's. So this combines, yeah, 9m. And what about the number portion here? 6. Okay, now next. Subtract 6 from both sides. We have 9m equals 27. Ready to finish it off.
27 divided by 9.
Both sides by 9. Cancel. M equals 3. Okay. Oh, look at that 89. Oh, look at that 90. How can we possibly ignore that thing? Look at that thing. I have this weird feeling this will take the rest of the class. Find out.
Free to go. That's what you did it. Okay. Good. Not sure exactly. Right, so we make it over 6, right? When I make it over 6, 3 goes into the 6, doesn't it? See, let's do that. One sixth minus, that was an 86. Right, so 1/6 minus 86 is negative 7/6. Considering the time I have to kind of
in here a little bit. Did you guys get to this step? 5, 6, W minus 7, 6. And that equals 1/2. Now, what would you do next? That's right, free go. What do you think comes next?
You cancel out to negative 7/6.
How do I do that? Tell me how to do it. What do I do?
Positive 7/6.
Plus 7, 6, both sides. Now, I encourage you to keep the right side of your paper free for intermediate computations like I'm doing. So for instance, I'm going to do this 1/2 plus 7, 6 now. I need to make myself some spaces here. 1/2 plus 7, 6. Remember, they both, 2 goes into the 6, so just change the 1/2 to 3, 6.
10/6.
And 6, that's right. So here, 10 over 6, and what did I have under 5 over 6? Cancel as you're going, so you can keep track of that. So all I had left was the 5 over 6 W equals 10 over 6. Now, what would you do at this stage?
Get rid of 5, 6.
That's right. Multiply by the circle. Not 5 over 6 though. What's it gonna be? 6 over 5. That's reciprocal. Do it to the other side as well. And notice a lot of canceling happens. These all go. Now you're left with the stuff over here. Tons of stuff canceled. These 6s canceled, and even the 5s canceled within the 10. You'll have, as you can imagine, you'll have about 1,000 homework problems of this nature. Yes, sir. You get W two? That's right. It's each day. Whichever we get, right? You're trying to get common on this to 97, got that. All right, so you're able to. What is this? So. Gotcha, okay, good. So make it. 7, 6. You want to get the 7 click, right? So it should have a 10 over 6 over here. You're the same stuff, right in there. So when you added 7, 6, you didn't write that on there. Excuse me. All right, let's go ahead and stop that. And stop the recording.